Hey, today let's talk about the scientific method and how is it used within modern tech companies and also by some of the most modern frameworks out there. So first of all, let's start by what is the definition of the scientific method. The scientific method is an empirical method of acquiring knowledge that has characterized the development of science since at least the 17th century. So basically what happens is that the scientific method has defined 6 steps to make sure that something can be scientifically demonstrated. And these are going to be the next ones. First of all, there's going to be an observation or a question, somehow like a problem, that has been found and identified and that has to be explained. Then there's going to be the research. During the research process, you are going to try to understand that observation that you have formulated and see what is the depth, the potential consequences, and why it behaves on a certain way that it does. Next, you are going to come with a hypothesis. Your hypothesis is going to try to explain the observation that you have found initially and explain what's the reasoning for that observation. Next, you are going to run experiments. The idea with running experiments is that you are trying to validate the data and the observation that you have made. And you want to validate with as many examples, so many cases as you can. Once you have run the experiments, obviously you are going to have a lot of data that you want to analyze and crunch through. This means that you have to be able to monitor and to extract the data and understand the conclusions that it gives. This is a very important step because one of the things that the scientific method relies on is in making sure that the observation always repeats itself. Otherwise, the hypothesis is not going to be good. So in the moment that you find one case where the hypothesis doesn't run and the data doesn't comply with the results that it should, then the hypothesis will fail. Or it has to be further analyzed to understand what is the reasoning why it fell. Is there actually something wrong with the actual hypothesis, or whether there's some kind of a fringe conditions that actually affected the experiment and affected the results. Finally, you want to communicate the results, and you want to communicate the results of your experiment, of your findings, of your hypothesis, and also the question that you were asking yourself initially, and communicate those to the rest of the community out there. So what in practice means is that the scientific method means that any observation for the question that you originally were proposing to a community has to always be consistent and backed by data. And this is how you can come up with theories or hypotheses of why is the reasoning for a certain behavior to happen. And as I said earlier, it's very important that the results are consistent. So when results are not consistent, then the theory by itself fails. Of course, you probably know modern ways of working and principles like Agile, Lean Startup, design thinking, and all of these methods and methodologies, principles, however you want to call them, they are probably not frameworks as such. They actually are somehow based on the scientific method. If you think about how the scientific method is described, when you have all these different steps of observing, researching, cramming with a hypothesis, testing with experiments, analyzing the data, come up to conclusions, and communicate, you can have very easily draw very similar steps when you're thinking about design thinking, where you're talking about the next steps: empathizing, defining, ideating, prototyping, and testing. Or you can have the same when you go to, for example, the build, measure, learn framework that Eric Rice proposes within the Lean Startup. The reality is that when you think about all these ones, they are actually mapping some of the steps and sometimes simplifying them and sometimes going in more detail on how to create or drive some of those steps. So for example, when you think about design thinking, it's taking maybe a more human approach, for example, in talking about empathizing, not necessarily just describing a question. And you could say that, of course, the build, measure, learn is simplifying quite many of the steps and just covering in 3 of them. It doesn't maybe necessarily and explicitly tell where the original question or problem is. So as you can see, all of these methodologies are trying or getting inspiration from the scientific method. And they're in many ways following the same cycle. But there's potentially one fundamental difference. What they're trying to do is usually they're trying to speed up the process, and they want to make this process a very iterative, moving fast process. And this can be for many different reasons. Usually The scientific method, especially how it is applied in research, when you think about how it is applied, for example, in universities, it can be a relatively slow process. Many companies and many startups, what they want to do is they want to do this as soon as possible because, first of all, they might be running out of money. Second of all, some companies might be very worried about bringing value to their users as soon as possible, because probably that's also what keeps them in business, but it's also a very acute problem that customers might have, and maybe another competitor potentially is going to come with a similar solution for those customers at a relatively close time. But in the end, all of these frameworks are trying to do the same. They want to make sure that you understand and you are asking all the right questions, that you are actually validating them, that you are creating and generating those hypotheses, that you are able to experiment with certain users or certain use cases, that you are able to analyze the data that you get, and that you are able to draw conclusions and communicate them to the public out there. This can be your stakeholders, or it can be just a scientific paper that is communicated to everybody else because we have found out, I don't know, travel at the speed of light. We can always dream. So what are your thoughts about this scientific method and all these frameworks? Do you think that they are related to each other, or do you just think that, no, probably not, they are just going for a very, very specific case that is not very related actually to what the scientific method is doing? Actually, Eric Rice within his book, The Lean Startup, is talking about a lot the scientific method and how this is the build, measure, learn method is actually very heavily based on the scientific method. Leave your comments below. If you like the video and if you like this type of content, please give it a like. It helps a lot the channel, and it helps a lot understanding what are the videos and what is the content that you like. If you're interested in learning more about the Build, Measure, Learn framework by Eric Rice, go and check out this video. I will see you in the next one, and remember, stay safe.